Right? So my goal today is I've got a stack of papers to hand back because you guys did a great job yesterday of turning stuff in. And so I got all those graded last night, and then I'm going to hand those back today throughout different times today. I'm going to try and cycle through what you guys are doing. I'll give you guys problems to work on and all that fun stuff. Okay? Anybody know why teddy bears are never hungry? Close. Because they're stuffed. Yep, they're all stuffed. Okay. I don't know who that is. Somebody's calling it. I don't know who that is. We're going to send that one. Yeah. All right, so if you guys could do the 2 warm-ups, please. 2 warm-ups. We're evaluating expressions under certain conditions. We're going to use this a lot today, or this concept a lot today. So if we have an algebraic expression, in this particular case, it's 2x plus 1. Okay? And we say that we want to evaluate it at x equals 3. What do we do? Nope. Not yet. Gotta do something first. What do we do first? We plug what in for what? 3 for x. Yep, we're going to put this 3 in place of x. Okay? So we're going to have 2 times 3, then plus 1. Okay? Then it becomes a please excuse my dear Aunt Sally problem. PEMDAS, order of operations. Multiplication comes first. 2 times 3 is 6. 6 plus 1 is 6 plus 1 is 8? 7. 6 plus 1 is 7. This one evaluated at 3 is 7. Okay? Same thing if we have fractions. That's the only thing that's different. Here is now our expression. Here is the x value that we want to evaluate it at. So it's going to be 2/3 times 6, then plus 1. Okay? So 2/3 times 6 is like 2/3 times 6 over 1, which is going to be 12 over 3. And 12 divided by 3 is 12 divided by 3. 4. Okay? So then we got 4, and all this is always going to be plus 1, plus 1. And 4 plus 1 is 5. So the answer there is 5. All right, so today we're going to deal with 2 concepts then. We're going to deal with 2 different ways to prove that a point is or is not on a line. Okay? The first way is going to be graphically. Okay? So we're going to have a line on our graph. I put a green line over the top of that one just so we see which one it is. Okay? So the first way is graphically. So we can plot these points, and if they fall on the line, then they are on the line. Okay? Or when we plot them, if they're on the line, they're going to be. Okay? So for instance, point A is 3, 1. How would I go about plotting point A? I need 2 directions and 2 numbers. From the origin. The origin is that crosshairs right there. That's the origin. Okay? So how do I get to point A, which is at 3, 1? Write 3 times, and then up 1. Okay? So write 3, up 1. 1, 2, 3, up 1. Is point A on our line? Yes, point A is on our line. We've proved it graphically. Okay? Because it was there, it was on our line. Okay? Now, I'm going to jump down to letter D. Okay? Letter D says we need to plot point 10, 12. What's the problem? I think, Lily, you just got to it. What's the problem with the point 10, 12? How far did you get out? 7. Our grid only goes out to 7. So it's off the grid. And so then we're kind of guesstimating, and we're not just kind of doing it. So the plotting the points doesn't always work, okay? Especially in something like point D. So there's a second way, and that second way is algebraically we can prove if a point is on the line. So what we have is we have an equation of a line. That is what's called the equation. Come on now. There we go. Just change the colors. Okay. So that's the equation of the line. And so what we're going to do with that is we're going to say y equals x minus 2 is our equation. We're going to take our point A, and within our point A, we've got an x value and we've got a y value. Because remember, points are x, comma, y. And what we're going to do with that then is we're going to put in 3 for x, and we're going to put in 1 for y into our equation, just like we were doing in the warm-up. Except now, instead of just plugging in 1 variable, we got to plug in for 2 variables. Okay? And then we check that math. 3 minus 2. 3 minus 2 is 1. So this is 1 equals 1. Is that a true statement or is that a false statement? That's a true statement. So if this is a true statement, that means then that the point is on the line. If that was a false statement, like 17 equals 3, okay, then that point is not on the line. Okay? Let's try letter B here just to see if that one is on the line. So here is our point B. We need to plot it. Negative 2, 3 means I'm going to go which direction 2? Left 2, and then up 3. So left 2 from the origin, 1 and 2, up 3, 1 and 2 and 3. So point B would be right there. Is that on my line? No. So graphically, that's not on my line. So that's a no, not on my line. Algebraically, we're going to start with our equation again. Y equals x minus 2. X and y. 3 and negative 2. Negative 2 minus 2. Negative 2 minus 2. Negative 4. And that there is our false statement. So therefore the point is not on the line. Okay. Point C. Is point C on our line? Yeah? Because we go which way? Left 1, and then down 3. Left 1, down 3. Left 1, down 3. Whoa! Tap the brakes. What happened there? What's going point C right there, is on the line. So if we try it, if we put it into our equation, y equals x minus 2, then we would have negative 3 and negative 1 equals negative 2, negative 3 equals negative 3. That one is. Okay. What about point D? So point D we can't plot because it's way off of our graph, but is it on the line? That's my question. Yay or nay? You tell me. You try point D algebraically. Plug your x in to y equals x minus 2. Plug your y in there. Plug your x in there. You tell me on the line, off the line. On or off? Well, 10. 10 minus 2 is 8. Is 8 equal to 12? So is it on or off the line? Off. Now, then it goes on to say here, find one more solution point for this equation. Show it graphically and show it algebraically. Let's call it point E. As long as point E is on that line somewhere, as long as point E is on that line somewhere, it's going to be what's called a solution. Okay? So wherever you want, it's got to be on that line. I'm going to pick my point E right there. My point E would have the coordinates 1, 2, and 3. So that would be negative 3, 1, 2, 3, 4, and 5. Negative 5. That's going to be my point E. Yours doesn't have to be there. It could be any other point as long as it's on that line. So I'm going to choose negative 3, negative 5, and then I know it is because I picked it on there, but then algebraically to show it, y equals x minus 2 was my equation. Negative 5, negative 3 is that, minus 2, then I get negative 5 equals negative 5. Checks out. Still. Back side of that work or of your note sheet now, I would like you to try. No, actually, you don't have the breaks. I forgot. We got to do this one together because it's different because we don't have the line now. We're determining if points are on the line. So on this one, we don't have a line drawn for us. So we can't graphically see if a point is or isn't on the line. So instead, what it's asking us to do is we're going to use algebra to determine if the point is on the line. So let's first get, here is our line equation, y equals 2x minus 1. That's where we're going to start. My x is going to be 1. My y is going to be negative 1. Might have to do a little more complicated math, but we can handle it. We plugged points into equations before. 2 times 1. 2. 2, then minus 1. That's going to be 1, right? Is negative 1 equal to positive 1? No? So this point is not on our line, and according to our directions, I am not going to graph it then. So I am done with point A in this particular problem. Okay, let's go to point B. Point B says I need to check and see if that goes into y equals 2x minus 1. My y value is negative 7. My x value is negative 3. 2 times negative 3. Two times negative 3. I like this better. You gave me negative 6. I didn't do the negative part. Sorry. Okay. 2 times negative 3 is negative 6. Negative 6 minus 1. Negative 6 minus 1. Negative 7. Yep. And is negative 7 equal to negative 7? Yeah? So is this point on the line or off the line? On the line. So therefore, because it's on the line, I've got to graph it. Negative 3 would be left 3. Negative 7 would be down 7. 1, 2, 3, 5, 6, and 7. So right there is my point. You try C. Tell me if C is on the line or not. C, on or off the line? Y equals 2x minus 1. Y is negative 3. X is negative 1. Equal 2 times negative 1. Negative 2. Negative 2 minus 1. Negative 3. Is negative 3 equal to negative 3? Yes. So this point is on our line. So graphing the point negative 1, negative 3, left 1, down 3, that would be my point C. Now, how many points does it take to graph one individual line? It takes how many? It takes 2 points. Did we just find 2 points that are on our line? Yeah. So remember at the start of class when I said you needed something straight? This is where you need something straight now. Because now you have to draw in that line. You're going to connect point B to point C, and you're going to extend it all the way across your graph. So again, if you don't think that you have something straight, I challenge you that you have the edge of your 3-ring binder. You might have a ruler. You might have a protractor. You have another sheet of paper. You've got an ID. You've got the edge of a phone. You could take the paper that you are literally drawing on and you could fold it over and so that it fits and all that fun stuff. You have enough stuff in order to do this problem, right? Right? Especially if your eyes are open, okay? So when you draw your line, you should draw your line in such a manner that it goes all the way, like don't do this, okay? Don't just draw your line like that, okay? You should draw your line so that it goes all the way across your graph. So that there's arrowheads, you got to put the arrowheads on the end of your line. you want those arrowheads to be off of your grid. Okay? You want to go all the way across your graph. Okay? Now that we have a line drawn on our graph, now we can just use graphically to determine if the point 2, 3 is on our graph. So point B was there, point C was there, 2, 1 and 2 to the right, 3 up, 1, 2, and 3. There is point D. Point D is on our line. I'll quick do the algebraic one. Point D is on our line. I believe it asked us to find another point on the line. Is there another point that it goes through, that our line goes through? Pick one that we haven't done already. We chose that one right there. What are the coordinates of that point? Let's call it point E. Coordinates of that point. 1, 1. Yep. Algebraically, y equals 2x minus 1. If I do 1, and I do 1, and I do 2 times 1 is 2. 2 minus 1 is 1, and 1 is equal to 1. That one works. Okay. What I'd like you to do now is I would like you to determine if number 3, 1, I want you to determine any of these points that are on there, on that line, and then draw in that line. So do number 3 right now. You tell me which points are on the line. A is on the line. I would agree that A is on the line, and we can do that because our equation is y equals 3, so I only need to put in 3 there, and then that's going to be 3 equals 3, and that is a true statement. So yes, A is on the line. B, yay or nay? B? Yeah, B's on the line. Because again, if I plug in y equals 3, I'm only plugging in that y value, and that's just 3, and 3 is equal to 3. So that one's on the line. So the point 1, 3 is right there. That's the point A. Negative 3, 3 is right there. That's the point B. I have now enough information to draw in my line right there. C, yay or nay? C is not on the line. Okay, because the point 3, 2 would be right there, and that's not on the line. D, yay or nay? Yep, because the 2, 3 is right there, is D. Okay, so that's a bad line. Get it? Bad line. Okay. Give me another point on the line. Negative 1, negative 3 is not on the line. I promise it's not on the line. Because what does my y value have to be in order for it to be on the line? My y value's got to be 3. So you could put any number here, as long as you've got a 3 there, it's going to be on that line. Okay? So I'm going to go 17, 3. And it's on the line. Y equals 3 with my equation. 3 equals 3. Okay?